Okay, this is the last part for hypothesis testing. So this will be the 3 examples for the mean, where we're doing a t-distribution instead of a z-distribution. And so I want to go back to the notes, previous notes, just to talk about a t-distribution for 1 second, and then we'll get into this problem. And I'll show you how to find the t-critical value for this one, just so you know, because I think I said I'd do it on one of the practice solutions, which is, I can do that there too, but I think it'll be okay to go ahead and do it now since I've split these videos up into parts. So if you recall here, this is from the notes for confidence intervals. And so when we don't know sigma, we use a t-distribution. So the properties of a t-distribution are that it's still bell-shaped and symmetric about the mean. Let me come back to degrees of freedom in just a minute. Total area under the curve is still 1. Mean, median, and mode are all 0. So the degrees of freedom is found by taking your sample size minus 1. And as that number increases, then your t-distribution gets closer and closer and closer to the normal distribution. So basically, the t-distribution allows you to do the problem the same way that you would do for a normal distribution. So it's basically just something that allows you to still complete the problem the same way. To find t critical values, like to find the z critical values, we do inverse norm. To find t critical values, you're just going to use a chart. So that's the properties of the t-distribution. So we'll get started on this example 5, and I'll show you how to find a t critical value. So what we have here is a simple random sample of 25. So there's our n. Filtered 100 millimeter cigarettes is obtained, and the tar content of each cigarette is measured. The sample has a mean of 13.2, so that's x bar, and a standard deviation of 3.7, which is all from that sample. It never switches to population, so this is S, not sigma. Use a 0.05 significance level, there's alpha, to test the claim. So here they're going to give us the claim that the mean tar content, so the mean of filtered 100 millimeter cigarettes is less than 21.2 milligrams, which is the mean for unfiltered king size cigarettes. And then it asks you a question, which we'll talk about at last. So step 1 is the same. You're still going to write the hypotheses. So for this one, it's a strict inequality, so it goes with H1. That's our claim. The opposite of less than is greater than or equal to. You still write reject and support. So this time, claim is next to support, so we're going to use the word support when we interpret it at the end. Step 2 this time is, instead of writing sigma, we know S. We do not know sigma. So sigma is not known, which means on the calculator you're going to do a t-test. So I'm going to go ahead and do the t-test, and then I'll talk about the t-critical value. So what we're going to do is, on the calculator, you're going to go to stat, go over to test, and go down to t-test, and we input our values just like we were for z-test. Right hand side's 21.2. X bar we have is 13.2. Oh, whoops, didn't type. Oh, what's it doing? Okay, let's try again. 13.2. SX, which is the calculator notation for sample standard deviation, is our S. It's 3.7. N is 25. And our H1 is less than. It's already there, so click calculate. So let's see, you get this T, which these T's are going to be different than Z's, most of the time for Z's, you know, we're dealing between -3 and 3. But for T's, they can kind of be all over the place because they're not completely a standard normal distribution. They just operate like one. So that's okay if the T looks a little strange to you. And to find a T critical value, so if you wanted to do this by hand, for a T critical value, the notation is T sub alpha divided by 2, which is the same as Z sub alpha divided by 2. You have to know your degrees of freedom. So DF, which is n minus 1, so it's 25 minus 1, in this case would be 24. We still need to know alpha, if it's in the left tail, right tail, or both tails. So for this one, our H1 is less than, so alpha, which was 0.05, is the area in the left tail. And the reason that's important for T is that it's in one tail. Because for T's it matters if it's in one tail or two tails. When you look at the chart, it tells you what column to look in based off whether it's in one tail or two tail. So for this T critical value, what you're going to do is I have a chart linked on this section. Should take you to this screen if you click it. And this one actually says, this chart lists the degrees of freedom up to 200. Generally, you're not going to have that many. Most charts don't list that many. And then if your degrees of freedom is not listed on the chart that you're given or that you have, you just go down to the one that's closest. So you get as close as you possibly can. So this chart actually has more than what most charts do in most textbooks. So when you go to this chart, it looks like this. So you see here it says alpha in one tail versus alpha in two tails. So that's why I said it's important to know, is alpha in the left, right, or both. You need to know if it's in one or two. It is important for the left and right too, but you need to know if it's one or two to shows you which one to look at. So for our problem, alpha is 0.05 in the left tail. So we're going to look at this first column here. 0.05 in one tail. Our degrees of freedom, that's given right here, over here, DF. So ours was 24. So scroll down to 24 for degrees of freedom, which is here, and go over to the first column. It says 1.7109, which is fine. So this would be 1.7109, but you have to remember for T charts, it gives you all positive numbers. If this is in the left-hand side, then this is a negative. So the trick with these is to remember for the chart, if it gives you, if it's a left-tailed test, alpha's in the left tail, so our critical value is going to be negative. If it's a right-tailed test, the alpha's in the right tail, so it's going to be positive. And then if it's a two-tailed test, you're going to use a negative and a positive. So our T critical value would be negative 1.7109. So you have to remember to write down the negative, even though the chart's only listing out positives. So you could complete this problem using that information, that critical value, and this T test statistic, because we would have, it would look similar to what Z does. Maybe if I can draw it. Our critical values, negative 1.70 or negative 1.7109. Alpha's over here. This is 0.05. That's alpha. Our T value that it gave us when we did T-test is here. It's negative 10. This big number down here. Like I said, T is a little bit different. Negative 10 point whatever. Let me just put 8. So it is in the rejection region, so you are going to reject. So that's one way to do it. You don't necessarily have to know how to do this, because you can do these T-tests on the calculator without ever paying attention to what the T critical value is. It's just, since we've talked about T's, I just wanted you to see how to find the T critical value at least once, just so you kind of have an idea of where it comes from. Most people, what they're going to do is they're just going to write down the P value. They're going to ignore that T altogether, which is okay. P anytime you see the E, you can just write it as a 0. It's 5.249 times 10 to the negative 11. That's what that means. So you could just say that that's approximately 0, or if you want to put the little plus sign like we used to, 0 plus, whatever you want to say is fine. So compare P to alpha. So 0 basically to 0.05. 0 is less than 0.05. So you're going to reject HO. P is low, we reject. So same answer. You rejected down here, we rejected over here. But like I said, when you do these, you probably are not going to have this part. You're just going to write that right there. So if we reject HO, that means we cross out it and circle H1. So when we interpret, our claim is next to support. We have it circled, which means we are supporting it. So we're going to say there is enough evidence to support the claim. So the question says, what do the results suggest about the effectiveness of the filters? So if you're supporting their claim that the mean tar content is actually less than what it is in an unfiltered cigarette, that means that the filters must be working because it brings the tar content down. So you can say something like filters appear to be effective, or something like that, because the goal in a filter would be to bring that tar content down. So, and we supported that, so they appears to be effective. So filters appear to be effective. I guess I need an S there. So two more using the t-test. Oops, maybe. So for number 6, we have the National Highway Traffic Safety Administration conducted crash test of booster seats for cars. Listed below are the results from those tests, given in HIC, which is standard head injury condition units. The safety requirement is that the HIC measurement should be less than 1,000. Use a 0.01 significance level, so there's alpha, to test the claim that the samples that are listed here is from a population with a mean less than 1,000. So we're going to write our hypotheses. This is strict, so it goes with H1. Opposite of less than is greater than or equal to. Still write reject and support. Step 2, it didn't actually give us any data. It didn't give us an X bar or S or sigma or anything, which is fine. You can find all that, but you can do these tests using the input on data. So we're going to type that list into L1. You're still going to do a t-test on this because it did not tell you sigma, so sigma is not known. So we will use a t-test. So what we want to do first is go to stat and edit. Type those numbers in. So we've got 774, 649, 1210, 546, 431, 612. And then once you're done with that, get out of there. That's not, I hit the wrong button. Let me delete that. Okay. Hit second mode to get out of there. Maybe if I can actually hit the right button. Okay. Go to stat, go to test, do t-test, because we don't know sigma. But we switch our input to data and hit enter. The right hand side is 1,000. The list is in L1. If you put it in somewhere else, you can change that, but it should be L1. Frequency, you don't worry about, you leave it at 1. Our H1 is less than, so it's already there. Go to calculate. And there it gives you your T, which, like I said, most of the time, most people are going to ignore. You're just going to do the p-value, which is 0.0224. If you were going to use this T, if you wanted, just so you can see, to do the T critical value, we have, for this one, you need the degrees of freedom, which we've got 1, 2, 3, 4, 5, 6. So degrees of freedom would be 5 for this problem. If we do n minus 1, 6 minus 1 is 5. And then we're less than, so again, alpha is the area in one tail in the left tail. So alpha is area in left tail. So you would go to your chart. You're looking at alphas in one tail. It is 0.01 this time, so you're going to go over to 0.01 in one tail. Our degrees of freedom is 5, so we're going to go down to 3.3650. 3.3, yeah, 3.3. So we would have our T critical value is 3.3650, except it's in the left-hand side, so you have to remember again, make that negative. So if you wanted to do it that way, that would be your T critical value. And then you would compare this T, negative 2.66, it would be above negative 3, so it would actually be outside that region, so you'd fail to reject. But like I said, most of you are not going to choose to do it that way. You're going to do it this way because it's a little bit easier, which is fine. I just like for you to know how to do it. Or if you see something else somewhere, you kind of have an idea of where it came from. So compare P to alpha. 0.0224 is greater than 0.01. So P is greater than alpha, so we fail to reject, which is what I said if you use T's. T in the critical value. So if we fail to reject HO, it means we can't cross it out. We have to circle it. We cross out H1. So when we write our interpretation, claim is next to support. I have to use the word support. I have a big X through it, so I'm obviously not supporting it. So I'm going to say there is not enough evidence to support the claim. It's not a very big sample size. If you only take a sample size of 6, it's kind of, you know, sample sizes, the bigger they are, the better results you get. So for our last problem here, a simple random sample of 40. So that's our N. Recorded speeds in miles per hour is obtained from cars traveling on a section of Highway 105 in Los Angeles. The sample has a mean of 68.4 miles per hour, so there's X bar, and a standard deviation of 5.7. There's S. It doesn't switch to population, it's all based off that sample. Use a 0.05 significance level, so there's alpha, to test the claim that the mean speed of all cars, so our claim is that the mean speed, so the mean, of all cars is greater than the posted speed limit of 65 miles per hour. So generally people do go over the speed limit, so it's a good chance that this is probably true, but test this claim. Strict inequality, our claim goes with H1. Opposite of greater than is less than or equal to. We still write reject and support. So this time claim is next to support, so you're going to either support it or not enough evidence to support it. It did not give us sigma, it gave us S, so sigma is not known. A problem may give you both, but generally they're not going to. If they give you S, they don't give you sigma. If they give you sigma, they don't give you S. But you may potentially see both in some problems. So we do t-test since sigma is not known. And I'm just going to do this one like most people would do it. I'm not going to worry about the t critical value or anything. If you want to know what it is, you can send me a message. But most people aren't going to choose to do it that way. That's not the easiest way. So go to t-test. So stat, test, and t-test. Our input this time, we switch it back over to stats. Our right-hand side is 65. Our X bar we had listed as 68.4. SX for calculator is our S, which is 5.7. N, it says is 40. And this time our H1 is greater than. Let's go over to greater than, hit enter, click calculate. You get P is 2.7 if I round to 1, times 10 to the negative 4. So I said anytime you see the E, you can do 0, which is fine. This one, negative, moving the decimal places 4 to the left isn't as bad. So if you want to call it 0, that's fine. If you want to use 0.00027 or 0.0003, that's fine too. Compare P to alpha. So whichever one you're using, 0.05 is alpha. P is less than alpha. If P is less than alpha, P is low, we reject HO. So if we reject HO, we've crossed it out. We circle H1. Our claim, like we said, is next to support. We have to either support or not enough evidence to support. We have it circled. So we are going to say there is enough evidence to support the claim. That the mean speed of all cars is greater than 65, which you could have guessed because most of the time people go a little over the speed limit. So that's the last problem on the notes. If you have any questions, please send me a message. This part is the longest thing that we do. It's probably the most difficult, but if you do like I do and label or go over to the side and write it down, or whatever you need to do to make sure you keep track of your stuff, then it helps. If you write out step 1, step 2, step 3, step 4, and step 5 and follow that, it helps too. So on your homework, you're going to write hypotheses for this one. First 3, that's all you do is basically step 1, you're just going to write the claim and then write H0 and H1. H0 has equal to, H1 is strict. And then it says for the hypothesis testing, you're going to write the hypotheses, label your claim, make your decision, show your work, and interpret. So basically, do what I've been doing, step number 1, step number 2, step number 3, step number 4, and step number 5. And this one, number 4 here, if I read it real quick. This one does the standard deviation of 3.5 minutes. It's all based off that sample, so this one should be t-test. Number 5, you have, anytime you see a percentage, generally speaking, you're going to be talking about a proportion, which you are here. You've got 254 are in favor, so 54 out of the 200. So that one you're going to do the 1 prop z test. For number 6 here, that one's a mean. You find the previous study that says the standard deviation for all costs, so that implies population, is this. So that one's going to be a z-test. Number 7, anytime you're given a list of data, most of the time they're not going to give you sigma. You're going to have to do t-test, generally speaking, which is true here. So they give you the list, type it into L1 and put your input on data. So this will be a t-test. And then for your last one, this one is a sample with a standard deviation from the sample, so this one's another t-test. T-test is more common. Most of the time you don't know the population standard deviation, so t-test is more common to use than a z-test, because the whole purpose of doing them is to estimate, to do a test about the population based off that sample. So generally speaking, we don't know the population standard deviation, so this one will be a t-test. So there's 8 questions, so you're going to do 1, 2, 3, 4, 5 hypothesis tests completely, and then the first 3 just you're going to write the hypotheses for like the first step of the problem. So if you have any questions on that, please send me a message.